In this video, we'll be making our second programming project, which is going to be this, the snake game. So I'm sure everybody knows how to play this game. You have a snake which grows on eating the food, and the objective is to grow the snake as long as possible without hitting yourself or hitting one of the walls. So if you do any of those, you lose this game. Well, there are different variations of this game. Some have teleportable walls, that is, if you go through this wall, you end up coming from there. And some versions even have obstacles in between them instead of this free space. But we're not going to do any of those. We are just going to stick to the simple version with four concrete walls and empty space in between, right? So let's get started. Let's create a new project. It's going to be a console application, and the language is C++. Project title, let's say snake, and these things remain as it is, right? And now let's first start by defining the board. So if you remember from our previous project where we made our tic-tac-toe game, we had defined a 2D array or a matrix to hold the board, right? But here, if you see, you don't need that. Why? Well, in the previous game where we made the tic-tac-toe game, the board only had 9 elements, and we were concerned about all the 9 elements of the board, right? So we were concerned about what all the board contained. But here you don't have to actually be concerned about all the elements of the board. Here the board just acts as a background. The only things you are concerned about are the position of the snake, the position of the fruit, and the position of the wall. So other than that, you don't need to keep a track of other things. So here we are just going to print the board just like we print something on the console. So let's define a function for that. Let's say void board, and here we are going to draw the board. So let's first define the dimensions of the board, the width and height. So let's say the width is going to be somewhere around 50 characters. So since we are working on the console, you are going to see everything in terms of characters, or this is basically a substitute for pixels if you are familiar with graphics. And the height is going to be somewhere around, let's say, 25 characters. Now these two things are constant, right? So these won't change throughout the project. So if you want to make them as constant, so you can just say const over here. So this keyword will make these things as constants. And now I would like to introduce you the concepts of macros. So macros, let me write it down here. Macros, these are nothing but one-liner code, right? So let's say you want to define a function to calculate the square. So what you do typically is you write something like this, right? So int sq, and this will return x into x, right? So this is how you define a small function. But what you can do is, instead of defining it as a function, you can define it as a symbol. So when I mean symbol, what I mean is if I type that particular symbol, then this operation should be performed. So that is what a macro does. So the way you define macro is you put hash define and then you put the symbol. So let's say sq over here, and inside this whatever parameters you want to pass without any data type. So this is basically a symbol. And here you want to define the operations. So here our operation is x into x, so that is basically going to return as the square of a number. So here you don't have any assignment operators or return operators. All this means is whenever I say sq of x, it should do this particular operation. So if you say something like sq of 5, and here if you run this, you should be getting the output as 25. So that's how you use macros, and you can do the same with these two variables also. So the way you define it is hash define width is 50 and hash define height 25. So now whenever I say width, I mean 50, and whenever I say height, I mean 25. So now you can remove this, you don't need this anymore. So now the board is going to be two loops. The first loop or the outer loop is going to control the number of rows. So here the number of rows is defined by height, right? Because height is basically how down you go. So that is how many rows you have in your board. So I is less than the height of the board, and I plus plus, and inside this you will control the width. So int let's say j equal to 0, j is less than the width, J++, and inside this you are going to print something. So here if you observe this board, for every row there are two wall pieces, right? So every row starts with one wall and then ends with one wall. So since the default, you can subtract 2 here and then put those two characters. So you have one wall in the beginning of a row and one wall at the ending of a row. And then you go to the new line, and inside this, basically if the row number is 1 or the row number is height minus 1, that is if you are printing this row or this row, then you need to print all walls. So here we are just going to print out these hashes, or else you need to print out the empty space, which is basically this space, right? So now if you call your board function, that should print a board for us. So here we have the board. Now this board looks pretty squished to the left, so you can take care of that by adding a couple of tabs, and that will center the board. So now let's see how to animate things on the console. So if you're familiar with graphics, or even if you have heard about animation, you might know that animation is nothing but just fast moving pictures, right? So here if you want to animate something on the board, let's say you have some object on the board, then the way you animate is you will quickly move the position of that object and it will appear as moving. So to move something on the board or to place something on the board, you need to know about the coordinate system which the computer uses. So let's talk about that quickly. So you might have come across this Cartesian coordinate system in your math class, right? So you have a coordinate system where if you go right, the x coordinate increases, and if you go vertically upwards, your y coordinate increases, and this position basically, which is the intersection of these two axis, this is the origin, which is defined by this 0 0 coordinate, right? So this is the coordinate system you all have come across in your math class. Now what happens in a computer is this origin is shifted to this top left corner. So let me just clear this thing. So in a computer, your axes are defined as follows. So if this is the top left corner of the screen, that is this position where I'm pointing my cursor, that position is basically your 0 0 position. So this is your origin in a computer, and as you go right, your x coordinate increases, and as you go down, your y coordinate increases. So basically your y axis is flipped in case of a computer and x remains the same. So as you go up, your y is decreasing, and as you go left, your x coordinate decreases. So that's how the coordinate system in a computer is defined. You can use this coordinate system to move objects in your screen or even place objects in your screen. So every object is defined by a x coordinate and y coordinate. So if you put some point here, so it has some x coordinate, that is how much it has moved from the origin in the horizontal direction, and some y coordinate, that is how much it has moved from the vertical direction, right? So this is how the coordinate system of a computer is defined, and we will be using this system to operate on our board, right? So let's define an arbitrary object somewhere. So let's say our int x, which is the x coordinate, is going to be somewhere around 10 characters, and y is also 10. So that means that this is 10 characters from the left and then 10 characters down. So it will be in some arbitrary position somewhere. Let's just see where it is. So if I print that particular object, that is pretty simple to print. So if the coordinates match, you are going to print that object. So how do you do that? Well, I is controlling the height, right? So height defines how deep you are on the board. So that is basically the y axis. So you need to compare I with y and j with x. So if these two coordinates are equal, then you can say that your object is at that particular position and you can print something. So let's go with this 0 for now. So that is going to be our object. Now if I try to print this board, you will be getting your object here. So and this is 10 characters from the left and 10 characters towards the bottom. But if you see, this position is exactly not as a square as expected. That is because in console the next line has some gap, if you see over here. So this gap is much bigger than this gap, that is why it doesn't end up as a square. But if you're using some graphics library, then this will work, so it will exactly be as a square, so it will end up somewhere over here. So this could be the 10 comma 10 point. But here, since we are working on the console, the y-axis is much wider, or I should say much deeper than the x-axis. So even when you animate your snake, it's going to move faster on the vertical direction than on the horizontal direction. That's actually not a logical error. That's because of the property of console. You cannot do anything about that, right? So if you're using any graphics library, then that problem won't be there. So now let's see how to animate this. Animating is very easy. You just need to move the board, right? So let's say I will create an infinite loop here, and inside this we'll first call the board, and every time this loop runs, we will just increment the x coordinate. So when you increase the x coordinate from this coordinate system, your object is going to move towards the right? So now if you run this program, you should be getting some kind of movement. So here you can see that this O is moving towards the right, but you cannot actually see it as a movement. This is basically, it is just printing the board again and again. So if you have some way to update the board, then you can see the movement. So one way you can update is you can use your console command. So if I pull up my console over here, this is basically a PowerShell, but in Windows, or if you're using this code blocks in Windows, it's going to use your CMD as your default console, right? So in CMD, the command for clearing a screen is CLS. So if I type something over here and I type CLS, that thing is cleared, right? And if you're on Linux, the command for clearing is CLAR. And the way you pass in such shell commands or such console commands are, you include another library called CSTDLIB, which stands for C Standard Library. You might have come across this while making our tic-tac-toe game. This is the library which had our random function, and we will be using that random function in our code as well, right? So here, to send commands to the console, you use system, and inside this you write the command. So in my case, it is the Windows operating system, so I write CLS. And in case you're on Linux, you need to write clear, right? So let me just comment this thing. If you're on Linux, you need to write clear. And I forgot the semicolon. And now if I run this, I should be getting a movement. But if you see here, it kinds of flickers on my screen, right? So this board is getting updated, but it is annoying to see. So this you cannot actually control. So more technically, if you know about the FPS or the refresh rate, so you cannot control these things of a console. Console is not a property of the language or this ID, right? It is a property of the operating system. So you cannot control something from an external source which belongs to the operating system. So one way you can take care of this flickering is, instead of clearing the screen, this is happening because it is doing two processes, right? First it is clearing the screen, and then again it is drawing the board. So if you just overwrite the board as we used to do with our normal line. So if you remember from our escape sequences video, we had talked about an escape sequence called /r, right? So if you write something over here, let's say hello world, and here if I put /r and I type something else, so AS, then the first four characters, which are these four characters, are going to be replaced by the word AS. So now if I run this, I should be seeing ASO world. So that is because HELL has been replaced by this. That is because this /r will take the cursor from the end of the line and place it in the beginning. But we cannot use the /r over here. That is because we are using multiple lines, right? So you're printing around let's say 25 lines, because the height is 25, so you're printing 25 lines, and there is no escape sequence to get your cursor back a line. So /n will move your cursor down a line, but you cannot go up a line, right? So for that, I'm going to tell you a solution, but this is going to work only if you're on Windows. So let me write it down here. This is only for Windows, and if you're Linux, you need to find out a library which does that. So basically what we're going to do is we're going to pick up this cursor from the end of the screen, and we are going to go all the way up to the origin and place it back. So if you do that, instead of clearing the screen, you're moving the cursor, and when you print your data again, it's going to be overwritten on the console. So it looks like it has been cleared, but actually it has been overwritten instead of clearing. So this solution, what I'm going to give you in this particular video, will work only if you're on Windows. So if you're on Linux, you need to find out some library which will do that for you, right? So if you're on Windows, you need to include a library called windows.s, which will basically allow you to control the cursor's position on your console. And here what you need to do is, instead of system clear, you can do set console cursor position, and here you need to give some handle which is get std handle instead of std output handle. So if you don't understand what this means, it's okay. It's just, you can think of it as it's going to pick up the cursor from the end and it's going to put it back on the origin. And to put it back on the origin or any specific coordinate, you need to pass in a coordinate data structure. Well, coordinate is basically a simple data structure which is already defined in windows.h, and we will be using this. So if you're on Linux and you're using some other library to achieve this, you need to define this structure to follow along with this tutorial, which is basically a simple structure. It is something like int x and y. So this is the structure which is defined in Windows. So I'm not going to define this again. It's there in this windows.h, and that's what we are using over here to send the position to our handle, which will basically take the cursor from this position and then put it back to the origin. So the origin's coordinate are basically 0 0, so you need to pass that in. And now if you see, you won't have any flickering screen. You will have a neat animation going on your screen. So as you can see, there is no flickering, although you can see that cursor updates somewhere, but this is much better, right, instead of the flickering screen. So again, this solution is only for Windows users. So if you're in Linux, you have some other libraries like you have N cursors and many other libraries. A simple Google search will get you what you want, right? Now let us remove all these things. We have now understood how to do animation, and here what we are going to do is we are first going to define our snake. So go to File, New, and Class, and the name of the class is snake. And you can remove all these things, right? It doesn't really matter. You don't need destructor on all these things. We'll create if we want to, right? And here just click OK, and in snake.h we have this template code. So again, I prefer private to be on the top. So if you want that, you can follow this, or if you're okay with the structure it has given before, you can follow that too. It doesn't really matter. And here, first of all, we are going to decide what is going to be private and what is going to be public. So what are the features that we need our snake to have? First of all, it will have a position, right? The position of the head, to be precise. And next, it should have a length to define how long the snake is. And you also need a direction, and you also need a velocity, or you can say speed of the snake, so how fast it moves. So here, in case of velocity or speed, we are going to talk in terms of number of characters. So let me write it down here. That is basically, it is going to move 2 characters at a time, 3 characters at a time, and so on. So in case you're working with some graphics library, that's the same thing you do with pixels. So you say 3 pixels at a time or 5 pixels at a time. And since here we are on console, we are going to talk everything in terms of number of characters, right? So here let me define the private variables. First thing is, you are having to have a position, so it's going to be quad position. So again, if you're on Linux, you need to define the structure, and for using this quad, you need to include windows.h, right? So this is because this is a separate file, right? Snake.h is a separate file. So even if you are included in main, you need to include it again, but you can exclude this over here because once we actually include this file, you're going to include all these things. It doesn't matter even if you keep it twice because of this guard block. As I had explained before, this guard block, what it does is it takes care of multiple initialization. So here, as I've already included windows.h, now when I do hash include snake.h, it will take care of the fact that I've already included windows.h, so I don't need to include it again. But here, if you want to use these things, you need to definitely specify that you're using windows.h, or else you cannot use this and it will throw you an error, right? And here you need a length of the snake, and you have a velocity, so int vel, and you have a direction, so let's say char direction. And in the public section we need to define constructor first, and this is going to take a position, that is the initial position, and initial velocity for our snake. So let's define this constructor and snake.cpp, and here we need to again specify those things. So chord position and int velocity, and here you don't have to include windows.h. That is because again you are including snake.h, which comes with windows.h, so you don't have to include it again. And here you need to set the position and velocity. So since I'm using the same name for both the variables, I need to use this pointer. So if you are not using the same name, it's okay, but if you are using the same name, you need to use this pointer. And the velocity also goes in the same way. And initially the length is going to be 1, that is because you have one head, right? So without the length cannot be 0 because you always have a head for the snake. So the length is going to be 1 initially. And the direction, so the direction you can say something like none, right? Because the snake is not moving now. And we'll have a method to change the direction of the snake. So let's say uh, change dir, which will change the direction. It will take some direction to change it. And here let's define that method. It's void snake change dir, char dir. And what you need to do is direction equal to dir. Basically I'm just setting the direction of a snake. And for moving the snake, let's create a move method or move snake. Well, move is basically a defined method in C++, so it's not preferable to overwrite it. You can overwrite it, you can define something like this, but it's preferable not to overwrite any uh, default method. So let's say move snake, and this is not going to take any parameters because it's just going to perform something. So void snake move snake. And here what you need to do is you need to switch the direction, that is basically you need to move the snake in that particular direction. So switch direction, and here you need to put different cases. So in case it is going up, then what you need to do, refer to this coordinate system, you need to decrease the y coordinate. So what we're going to do is pos dot capital Y minus equal to the speed. So basically if I say that my snake is moving 2 characters per second or 2 characters per iteration, then I need to subtract those many characters, right, to move, to appear to be moving in that much speed. So that is why we are going to subtract the velocity over here, or speed, you can name it whatever you want. And here the break is mandatory. And this is will be true for all the 4 directions. So let me just copy it down 4 times. And it's going to be up, down, left and right. Right is you need to increase your velocity, left is you need to decrease your velocity, and for down you need to increase your velocity on the y coordinate. So this will move your snake in your preferred direction, and that should be it. So now you have a snake, you have initialized it with some initial position and velocity, and you have a method to change the direction of a snake, and now you even have a method to move the snake. And here, since we need the position of the snake to draw it on the board, you also need a method to get the position. So let's say quad get pos, which will return the position of the snake. And this is going to be return pos. And I forgot to mention snake here. This will be declared as a normal function. If I forgot to mention this, this basically means that this get pause function is related only to the snake class, right? I'm sure everybody knows this. And here we'll quickly define a prototype for that. It's quad get pause and done. So now you have four methods. Let's go over it quickly. One is a constructor which will initialize our variables. One is a method to change our direction. So change direction of the snake, and one is to move the snake in that particular direction, and one is to get the position of the snake, or I should say get the current position of the snake. So now let's use this thing in our main file. So you here, as I told you, you can remove this windows.h because it is going to be included with snake.h. And here let us first create a snake. So snake s, let's say snake, and inside this let's say it's going to be initially in the middle of the board. So that's basically 50 by 2 and 25 by 2, or you can say width by 2 and height by 2. That makes more sense, right? So width over 2 and height over 2, that is basically the center of the board. And velocity, let's say it's going to be 1, that is one character at a time. And here you, instead of y and x, you need to capture the position of the snake. So chord snake pos, you can say, equal to snake dot get position. And here instead of y you need to say snake pos dot y, and instead of j you need to say snake pos dot x. So far so good. We have created a snake which is going to be on the middle of the board and which is going to move at a speed of one character at a time. And here let us just clear all these comments, and now let's see how to get input so that we can control the snake. So you need to move the snake only when you press something, right? So here, how do you capture that keystrokes? Well, you have a library to do that. So that is called conio, or I should say console input output. And here you can just do the following. So if you say if kbhit, so kbhit stands for keyboard hit. So it will be true if you hit a key on your keyboard, not necessarily enter key. You can hit any key on your keyboard and this is going to evaluate to true. And to capture your key you need to say get ch. So get ch will basically give you the key which you have just pressed. So we will capture this, and instead of capturing this we can switch this so that we don't have to write couple of if statements. We can just say switch get ch, which will basically give us the key, and here you can control it. So let's say up. So I'm not going to do it for the arrow keys because I don't really remember the ASCII values of the arrow keys. So if you want arrow keys, you need to give the ASCII value. So let's say 132 is the ASCII value of upper key. It is not the case, I'm just saying. But if 132 is the ASCII value for the up key, then you need to give something like this. But I'm just going to go with WASD for now. So case W, then what you need to do, you need to move the snake upwards, right? So snake dot change the up, sorry, u, and then break. And you need to do this for all the four directions. So control c, v, 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 w, a, s, d, and d is basically go to right, s is down, and this is left. For now, this will move a snake in our preferred direction, and to move the snake, you just call snake.move snake, which will move a snake. And now, if you run this, you will be getting a snake which can move on your command. So now you can see that it is not moving because initially we had set the snake's direction to be n, right? So we did not have any case which will move the position for n, so it doesn't move for any iteration. And now once I press W, you can see that it started moving up, A it started moving left, S it started moving down, and D it started moving to the right. So now I can control this little character and keeps moving, right? So that is how the snake game is defined. So once you press a key, it will keep moving in that particular direction until you change the direction. So this is what we needed, and we got a moving character on our board. So now let's see how to first generate the food and calculate the points, and then we'll talk about how to increase the snake's length once it eats the food, right? So now let us just close this and talk about the food. So again, you need to create another class for generating the food. So it's going to be, let's say, food. And again, you don't need the getter, setter, or the destructor. So create it, yes, okay. And here you have food.h. And again, I don't need these things. So here in the private section, what we're going to do is we are going to have a position of the food, right? So that is mandatory. You cannot have any object without a position, right? So for the position, you again need to include windows. So windows.h, and it's going to be called pause. And you do need a velocity. Well, you don't need anything else. You don't need velocity, you don't need any direction for that food. It's just going to be a point where if you go over to that point and then eat that food, you're just going to generate another food. So basically you don't need anything else. And in the public section we have a constructor. Basically, well, you don't have to pass anything to the constructor. It's basically going to initialize this position with some random value. But if you see this game, always this food starts at this particular position. If you want something like that, then you need to define a initial starting position. So as we did for our snakes, you need to do something like that, but we are going to go with random initialization right from the beginning itself. So again, for random function to work, you need to include cstdlib, and we are going to define a function called gen food. This is basically going to generate our food, and this is going to be void. And we also need function to return us the position, so it's going to be get us. So this will return our position. So let's define these functions. Inside this, what we're going to do is just generate food. Right, first time it's just going to generate the food once you create it. And for generating the food, sorry, food gen food. And what this is going to do is it's just going to generate two different random numbers in some range. So if you remember the formula for generating a random numbers in the range, that is u to l, it was basically rand mod u minus l plus 1, u minus l plus 1 plus L. So this was the formula for generating a random number in a range. So here our upper limit is going to be, for the x-axis is going to be width, and the lower limit is 0, right? So here you just need to say rand mod and then u minus L plus 1 plus L. So for us, the u is basically width minus the lower limit. Now lower limit, if you keep 0, then the food will have a chance of getting generated on the walls of the board. So you don't want that to happen, so it's going to be 1 and plus 1. So these two cancel out, so you just need to say rand mod width and then plus L, which is 1. Again, for the y-axis, the upper limit is going to be height and the lower limit is again going to be 1. So this will generate a random position for our food, which will be on the board. And for getting position, it's very simple. You just need to say pod food get position. So we did not define that. Well, we did code get position, and here you need to say return pos. So this will return the position of the current food. And that's it for food. So we need to include that also over here in our main file. So here we need to say hash include food.h, and here we don't need cstd again because we have defined it inside this food.h, so that gets included automatically. And here we need to create a food object. So below the snake, let's create a food. So it's going to be food. And as a constructor doesn't need anything, so you can just put it like this. And here we need to check whether the snake has eaten the food or not. So for that, what you can do is you can have a function inside the snake which will check whether its coordinates have matched the coordinates of food or not. So what you can do is you can inside the snake.h you can define another function called boolean, let's say eaten. This will basically say whether the food has been eaten by the snake or not. So you can just pass in some coordinates inside this, that is the coordinates of the food. So coordinate food, it's a food pos, and we'll define it inside snake.cpp. It's basically um bool snake eaten, and this will return true if the coordinates match. So if I say if food pos, well, I did not capture it over here, so it's called food pos. And if food pos dot x is equal to pos dot x, and food pos dot y is equal to pos dot y, that is basically if the position of the head and position of the food are equal, then it means that the food has been eaten by the snake. So then you need to return true, else you just return false. So this means that if you eat the food, it will return true, and if it didn't eat, it will return false. And in main, you can use that over here. So if you can say snake dot eaten, and you can get the food's position. So food dot get pos, and this will give you the position of the food which you can pass into the snake. And if the snake has eaten, then you need to generate another food. So you can say food dot gen food, and you also need to increase the length. So you can say snake dot length. Well, length is a private variable, so let's say snake dot grow, and we'll define a function to grow the snake. So you can say void grow, and we define it as void snake grow, which is length plus plus, and this should grow our snake, and that should be it. So now you have the logic for eating a food and then growing the snake. Well, we are not going to see the snake grow, but it is just going to grow in numbers. We won't be seeing that visually. We'll see how to deal with showing that visually, right? And here we forgot to draw the food, so here you need to put that. Else if our I is equal to food pos dot y, and j is equal to food pos dot x. Well, I did not capture that, so quad food pos equal to food dot get pos. Then for food, let's say the star, right? The star works well. Now if you run this, we have an error. What does it say? It says that width and height were not declared in the scope. Now that is because in food.h we did not define the width and height, right? We had defined it in the main.cpp. So you need to copy these two lines here. So control C and put it inside food.h. That is because we are using those two, right? We're not we did not define it in food.h. That is why it was giving an error. And now if you run this, we have another. It says has no member y. That is because this is a capital Y. And here you have the snake and the food. So here you can see the food. So if I eat that food, it's going to generate another food in some random position. So you can see that generated over there. And here we did not write the logic for collision, so we'll take care of that afterwards. Well, it's going to be in the same places. That is because we did not seed the random function. So if you have seen the previous video where we made the tic-tac-toe game, you know what is seed is. Well, to seed the random function, what we're going to do here is we're just going to say in the main function. So to seed the random function, what we're going to do is hash include seed time, and here in the main function we'll say is and time null, right? So now when you run it, you will have a snake and food, and this food will be generated once you eat it. So here I ate that food. Now you can see that another one has been generated, and then another one has been generated. So we did not write the collision logic. So if you go through the wall, you won't come back, and that will take care now. So to do that, what we are going to do is we are going to write another function. So it's going to say pool collided, and it's property of the snake. So snake collided, and this is going to just return true or false. So this is going to return true if our position of x is less than, let's say, 1. So that is because at the 0th position you have the wall, right? So if it is less than 1, it means that you have crossed the position of 1, and you have crossed the wall. And in case your x is really greater than height, then it means the width, then it means that you have crossed the other wall also. And similarly for the y, you need to say it is less than 1, or position dot y is greater than the height, then you need to return true. It means that you have collided with a wall, or else you return false over here. So we forgot to define the prototype, so here it is going to be bool collided. And in main function, instead of true, we are just going to maintain a variable called game over, which will track whether the game is over or not. So in the beginning, game over is false, and while true, you will change it to while game over, or while not game over. You need to run all these things. And if the snake collided, so if the snake collided, then you will just say game over equal to true, and this will stop executing the loop, right? Now if you run this, we got an error. Does it say again the width and height are not defined in snake.h? So we need to copy those two things from here and put it over here, right? Now if you run this, you don't have any errors, hopefully. And here you can see that the snake moves, and if I go and hit the wall, it ended the process. So now the game ends successfully once I hit a wall, and we have taken care of the food also. So I think that the video has become long enough. It has been an hour. So the next video we'll see how to increase the snake's length and show it visually. Well, we are increasing the snake's length over here, but we are not showing the increase in its body, right? So we are just moving the head and we are eating the food. And we made quite a progress, right? So let's see what we have made. We have made this board, and then we have updated the board without causing any flickering, and that's a great improvement. And we have also animated this character which can eat the food, and we have also written the logic for the food to appear at different random locations, right? In this video, we'll complete this game by adding the body for the snake. Well, you know that the snake is growing while eating the food, but it's just growing in numbers, right? We're not showing it visually. So we'll be showing that. And also before that, let's just fix some logical errors which were made. Right? So let's see what are those errors. So let's just try if one of the error pops up. But I'm turning unlucky with just to save the time. I'm just ending this game here. And let's first talk about the most obvious logical error. So in the definition of food, what we have said is once a food is created, I want a random location on the board which will be the location where our food is placed, right? That's what we said when we are calling this generate food function inside the constructor, right? But what is happening here if you run this program again and again? So let's run this once again. So here you will be seeing that the first food is over here. And if I close that, run that again, you will be seeing that the second time also the food is over there. But the consequent foods are getting randomized. So if you see the second food is somewhere over there, and if I start this game again and try to eat that, you see that the second food has been generated at some random location, right? The first one was somewhere over there. So to fix this, well, you can go with it. It's not actually an error. It is actually not what we wanted, right? It's basically what I did not want. But if you wanted that the first food should be generated like that, you can go ahead with this and skip this portion. But since we wanted to generate the food at a random position right from the beginning, what we are doing wrong is Here, first we are generating the food object, and then we are seeding the random function. Right? So if we were introduced to the random function and the seeding function back in the tic-tac-toe video, right? So if you remember, the seeding function is a kind of controller to the random number generator. Well, the random number generator will generate some random number. It will do some calculation and give you a number when the program is loaded onto the memory, right? So if you want a different random number, what you need to do is you need to close everything and then open it again. Well, we don't want to do that, right? We want random numbers right when we are in the memory. So what we do is we change the seed. So seed is like a starting point of the algorithm. And what we do is we seed it with some number every time we want to generate a new number. So what is the thing which is changing constantly? Well, time is changing constantly. So what we do is we just seed it with the time. So this one will take the time. It will take the time as an integer and then make the random number generator start from that particular time. That is why you get different numbers after seeding it. But what is happening here is we are calling the random function before seeding it, right? For the first time. From the next time onwards, once the food is eaten, the logic is over here, right? Which is after the seeding function. That is why you are getting randomized locations for the consequent foods, but not for the first food. So to fix that, it is very simple. What you can do is you can get rid of the constructor. Well, I don't know why I defined this constructor. Well, basically, when we define a constructor, what we actually see is we need the constructor to do something which the default constructor, which the compiler will construct for this class, can't do. Right? But what the default constructor does, it will basically create the memory required for this particular class, right? For loading this class onto the memory, you need some amount of memory which is calculated by the constructor. Well, we wanted the constructor to do something extra, that is called this function on the creation, and it did not work out as we expected. That is why we can just get rid of the constructor and then call the function manually. Well, if you want to keep the working of the program just like before, then you can skip the step as I told you. It's just preference, right? I prefer that the would be generated at a random location right from the starting. So you can go there, and after seeding the function, what we can do is we can now call the generate food method. So this is the one line which we wanted to skip by using the constructor, which was actually worthless. Right? So creating a constructor was more good, and at least for this kind of a game where we want the first element to be randomized. So it basically get rid of the constructor, and that will solve the issue. Now, if you run this, you will be getting the foods at different locations. So one is being generated over here. Close that, open that again. Well, so the other one has been generated, but this is the problem actually which I wanted to show you in the beginning, right? Well, when I was eating the food, I actually knew that at some point this will happen. That is, you won't see any food on the food. That is a major logical issue with this program which we made in the previous video, and we'll be fixing that right now. So here, if you see, there is no food on the board, but actually it has been generated. We'll see why that's happening. Okay, so close that, and now we fix the most obvious issue. Now let's go on to the issue which we just saw, that the food is not getting generated. Well, what we're doing in the generate food method, well, here we are saying that we want some random number in the range of 1 to with minus 1. Why? We told that the first character is basically reserved for the first wall, and the last character is reserved for the last wall. So basically you want numbers from 1 to with minus 1, leaving those two characters. It sounds reasonable, right? But if you work on the math, it is going to tell you a totally different story. So let's see what the math is. Let me pull up my paint over here. And now let's first talk about one of these, so width or height. Both of them are going to go with the same logic, so we can talk about only one of them, right? So here, let's say I draw the height. So what is the height? Height was something like 25, right? So the whole thing is actually 25 characters, right? And what we are saying that the first character and the last character are reserved for the walls. So from a computer's perspective, what are these numbers going to be? The computer starts counting from zero, right? So 25 characters is basically 0 to 24 for a computer. And what we are saying is we are saying that this 0 and this 24 is not required in our range. So basically we want numbers from 1 to 23. We don't want 0, we don't want the last character which is 24. Right? So this range becomes 1 to 23. Well, to get a number in this range, what you can do is plug it into the formula. So, what is the formula for random number generation? It is if you want a number from L, that is the lower limit, to U, which is the upper limit, and lower limit is included and upper limit is not included, right? So you will be getting some numbers till U minus 1. So if you want numbers in this range, that is L inclusive and U not inclusive, you won't get the U. Then the formula is you need to plug in rand mod. It was U minus L plus 1 plus L, right? So this is a formula. You can plug it into this formula. You can even see logically. Well, basically, both of them are going to give you the same result, and we'll just use the formula for simplicity purposes over here. What we can do is just plug it into this formula. So what it becomes, let me just write it as R. This is basically the random function R mod. And U is over here 24, right? Because we want 23 to be included, right? And in this formula, this particular U is not included in this random number generation. So we'll just increase this by one number, that is 24, and that will become 24 minus L plus 1, that is 1 plus 1. The lower limit is 1, which is included. That's why we don't have to do anything to it. And plus 1. So what this becomes is R mod 22 plus 1. And what is 22? It is basically 25 minus 3, right? So this is the number which we wanted to generate actually. But what we did is we basically went by our intuition and messed up the logic, right? So to correct this, what we need to do is using this particular formula, this becomes minus 3 and this will become plus 3, and the same will go with height also. Well, we talked about height, the same thing will go with the width also. So if you draw a similar kind of analogy, you will be seeing that the same logic will work for the width also. Right? So let me just clear that. And here it is minus 3 and this is plus 1. Now this will fix the disappearance of the food. And there is another major flaw in our looping, right? So where are we looping? We are looping over here, right? The board where we are displaying. There is a major flaw in that. And believe me, if you have been able to identify that particular error, you are going to be a great programmer, right? So let's see what the error is. It is basically lying within the inner loop. What we're doing? Well, for the outer loop, it is pretty straightforward. We are going from I equal to 0 to I equal to height, which is basically how the computer sees numbers from 0 to n minus 1. And for the width, we are doing something different, right? So what we're doing here, we are saying that we are going from 0 to width minus 2, and we had a reason that these two characters, which are basically the walls, are constant for all the rows. So instead of including them inside the loop, why not just exclude them and run the loop only for the width minus 2 number of characters? So that's what we did, and that sounded reasonable. But here is the problem. What happens is, let's say my generated x-axis, which is basically the width, is going to be 28, right? Sorry, what is the maximum range? Is 50, right? And what you can do, if this is 50, the maximum number you can generate leaving 0 and 49 is 48, right? So this is the maximum number you can generate, and let's say that that is our x coordinate, that is the value of our width. Now what happens here? Well, if you see here, j is running from 0 2 width minus 2. What is width minus 2? It is basically 48, and it's not reaching 48. It's just going till 48, which means it's going till 47 only, right? Now if you see this, you don't have a way to actually display this coordinate in this loop at all, because it is out of the bounds of this particular loop. This loop will run only till 47, and you are asking it to show something which is on the 48th coordinate, which is not possible by this loop, right? So how do we fix this? Well, we can draw an analogy over here. So if you draw the coordinates with the J's perspective and the W's perspective, W is basically the original width of our board. So see this, when W is 0, J is not at all defined. Why is that? Well, let me just clear this thing so that we can see it clearly. Well, this is the leftmost corner of our board, and this is 25, right? 25 characters or 25 pixels. And here, what we are doing is we are saying this is our character, the width character, and we are saying that the inner loop should run from 0 to 47, and we are including another character, and the total makes it 50, right? So 0 to 47 is 48 characters, plus 1 50, and this is the other one. Now what is happening is, let's say my coordinate is 0, right? Then the x coordinate is 0, it basically means this particular position where the wall is there, right? But what is happening here? Our 0 is starting from one step to the right because of this particular looping and this particular character before the loop. So what is happening? Our loop which is starting one step towards the right, and that is why we are missing out our coordinate. So what happens is, if if W, which is our original x-axis, is 0, J is not at all defined. It is not there at all. And when does J equal to 0 start? When width equal to 1, and so on. This will continue. When width equal to 48, J equal to 47, as we just saw, and width is 49, it is not present at all. Right? So this is the reason why we were not getting anything on the board. Not This is not the complete reason. The actual reason was because we were messing up the formula, the random number generation. But here, this is another one of the major reasons why we won't be getting even after fixing the random number generation. That is because if you create any food at the extreme positions, that won't be visible to you at all. Right? So to fix this, what we can do is, while comparing the coordinates, we need to add 1 to this. Right? So if 0 plus 1, well, we don't care about the 0 or the 49th coordinate. Right? We don't want these two things. Because we're not going to generate food at those two things. They are walls. They are reserved for walls. So in this range, 1 to 48, what you need to do, you need to compare only these things, right? You need to compare only these things, and to compare that, what we can do is we can add 1 to the j before comparing it with the x coordinate. So to fix this, what we're going to do here is, well, we need the canvas. Let me just clear this, and here in place of k, it's going to be j plus 1, and that should hopefully fix all the logical errors which are made. So save that, run that again, and here we have our first food. If you eat that, the second food is getting generated, and hopefully it should not stop generating. It should be generating till we play this game, and it should stay within the range of board, and it should be visible to the player, right? So well, if you see this is visible, and trust me, it's going to work, and there are no kind of mistakes in this program, and this is completely fixed now. Well, we'll fix one more thing, that is, if I go to this particular wall, I will crash before actually crashing. So if you see this, I have not yet crashed the wall, but it's in that I have crashed this wall. That means I need to go inside the wall. So to fix that, it's the coordinate issue and also a placement of moves. So let's first fix the coordinate issue. If we go there, snake.collider will have already fixed it. Basically, what we did was we had put something like this, right? Position.x is less than 1 and position.x is greater than width minus 1. So going by the same logic, width minus 1 is going to be 49 because width is 50. So width minus 1 is going to be 49. So what you want? You want something greater than 48, not 49. So it's going to be width minus 2. And that should fix the issue. And for the other wall, which I just showed you there, for the rightmost wall, what is happening is, we are first drawing the board, we are actually changing the direction of the snake, we are moving the snake, and then we are checking whether it collides or not. Basically, this movement is not shown at all. Right? This movement is not shown to the user. This movement should actually happen after this collision checks are on. So what you can do is you can just move this to the end, or you can even move it to the start. Doesn't matter. Basically, the board should be updated after the snake moves, not before the snake moves. That is what is happening over here. The board is actually getting updated before the snake moves. So that is why you're not seeing whether the snake has been collided or not. So you can just move this thing to the end or move this thing to the start. Basically, they both mean the same thing, right? So for the next loop, the starting point is going to be end of this one. So they mean the same thing. So just move this to the end or start, whatever you wish. Right? So this should fix that issue that you're not seeing the snake colliding, and now you should see that the snake actually collides with the wall before ending this game, right? So it went inside the wall and the game ended. And now everything is pretty much fixed. And now let's proceed to making the snake game a real snake game. What is that? We need to include the snake's body. We are just growing the snake, which is basically just increasing the length, right? So here you can see it's just increasing the length. So how can we store the snake's body? Well, what is a body? It's just a collection of body parts, and that collection must have triggered something inside you. Well, we are going to use something like an array, which is a collection, a vector, which is also a collection, which was seen in the pointers video, and the other thing is list, right? So these are three options available to us as of now, and we'll use one of this. Now let's understand what we need to use over here. Right? So array needs to have a fixed size while defining. And how do we know the fixed size of the snake? Well, if a player like me is going to play, he's probably going to get defeated in let's say 5 or 10 points at all, right? Because I'm a very bad player, and maybe a pro player comes in and he can make a score as big as 1,000 or 10,000, right? Well, you cannot restrict the players or you cannot estimate the player's capacity by just keeping a fixed number. What if the player is better than what you thought he should be, right? So here, what you can do is, well, in this particular board, you can actually fix it to some big number. So let's say the maximum number of characters possible is what? Well, here the width is let's see that width is 50 and height is 25, right? So the maximum number of characters possible is this thing, 50 times 25, out of which you're using the borders. So that is the only number of characters. So if you make the snake as big as that, after that there is no possibility of winning because the snake has to collide, right? Because the maximum free space has been used up. So basically it has to collide with one of the walls and you end the game. Well, that is a very cheap way. You don't have to do that. And while defining with graphics, we generally what we do is we'll take out such limitations, right? So that is why you have such teleportable walls and all to take care of this issue. But for this particular game, we won't be talking about the teleportable walls. Well, in the end, I'll show you how to create teleportable walls if you want to. And here, basically, the array is a very bad option because you are restricting the player's capacity. And if you talk about vectors, well, it is dynamic, but again, it is going to take up some extra space while defining. So if you remember how vector work, it first defines some amount of space, and once it gets filled up, it will define a bigger space, and then copy all the elements to this and get rid of this particular space. So this one could be used, this could work, but again, there is some extra space which is getting wasted. So basically, the best option here is going to be list. So if you remember from our video on the pointers where we first discussed when to use vectors versus when to use list, you saw that list can be used whenever you have a data structure where you won't be accessing the middle elements more frequently. You're just going to access the first and last element. That is the case here also, right? You're not going to access the middle elements, which is basically these body parts. You're not going to access it. We are just only concerned about the head, which is on the front of the data structure, and then tail, right? So we'll talk about how to actually manage the head and tail in a short while. But for now, the head is at the beginning and the tail is at the end, and we are only bothered about these two things. We're not bothered about the middle elements. Well, we are basically when we want to check the collision, we need to consider the middle elements also, but we can just do it in a progressive loop, right? So basically, it doesn't make any difference, and we can't actually harness the advantage of being able to pick some random element from in between. Well, in a vector, we can do that very simply because it is a continuous collection. But in a list, if you remember, it was something like this, right? You have pointer to something, and then you have another pointer which points to this, and so on. Right? So if you want to pick this thing, you need to cover all this way. But in a vector or in an array, you can just pick that up using the index. It is basically the starting position plus the number of steps you need to travel. So in this case, a list would be the best thing to implement, but to keep this tutorial simple, I'm using vectors for this particular demonstration. So I would totally encourage you to go with list, not with vectors, as we are going to see in this video. I'm just showing with vectors because it's easier to relate than this, right? But once you're comfortable by implementing this particular project in a vector, please go on to try it with a list. List is the most preferred option for such games where you don't have to control the capacity of the user. Right? Vector is not going to control, but basically the extra space is an issue. Right? We don't want that. So please try it with the list, and let's now move on to the logic of creating the body. Right? We need to just clear that. And how do we define the body? Well, it's really simple. So let's say I have two body parts, well, basically a tail and the head. I have this head over here, and the snake has to move to the right. So what can I do? Well, what if I just remove this tail and then put another head over here and make this as a tail? So for tail, let's just say this X mark over here that denotes a tail. Now, if you see that the snake has put one step to the right, right? And if I do that again, so I take out this tail, I include the head, and I make this head as the tail. Now the snake is moved again, and let's say we are eating the food at some location. So let's start with another snake. So this is the snake we have, and the food it is going to eat this particular food. So it has eaten. In the next iteration, what I will do is I won't take off this tail. Right? I will keep this tail, and this is what happens. Right? So I add the head. I won't remove the tail, but I'll make this head as a tail. Right? So now you have two tails and one head, and that basically looks like the snake has grown, right? From two body parts, it has grown to three body parts, and that's what we want, right? So this is the logic we are going to implement, and we are going to do that in vectors. Again, list is the most preferred option. Please try it with a list, not with a vector. After you're comfortable, basically. Right? So let's just go to our snake.h and quickly create a body definition. So we need vector obviously. So hash include vector, which I'm going to do it with a list, you know, right? Hash include list. And well, since vector is a standard scope element, you need to specify the scope. So using namespace std, like we did in the main function. And here you can just say vector body, sorry, vector, and what is the data type? It's going to be coordinates, right? Basically, so chord and then body, and this defines the body of the vector. Now there are few changes we need to make. What is that? First of all, we need to include the head to the body once we create a new snake. So in this snake chord constructor, what we're going to do, we're just going to say body dot pushback, which is basically pushing back the elements inside a vector. And what we need to push back, we need to push back the position, which is basically the position of the head of the snake, right? We can just body dot push back that particular position. And while moving the snake, following that logic which we just discussed, what we're going to do is first we are pushing the head of the snake to the end of the list or end of the vector. So how we do that? Body dot push back the new position which has been updated after all these things, so new position. And now what we'll do is if the body size is greater than the length of the snake. What is the length of the snake? That is the thing we are growing when the snake is actually eating a food, right? So that is the thing we are manipulating over here. So this length integer, if the body is size, which is basically the number of elements in the vector, is greater than the length, then what you do, you just take out the element from the body. So how do you do that? You just say body dot, and if you're actually confused with what function you need to use, the best thing I would suggest is not just memorize the function, but just use the resources. So you can just go to your web and then search something like CTP vector documentation, and you'll get a lot of resources, and c++.com is the best one among them. Well, I feel that this is the best one where you can find short descriptions of all the functions, right? And here you should be saying some function like pop back. What does it say? It says that removes the last element in the vector, effectively reducing the container size by one. but we actually don't want this. And well, why is that? If you see, well, technically the tail should be at the end of the body, but if you look at the structure, what we're doing is we are actually pushing back the head one step to the right, right? So this is what push back does. So basically, our head is over here and our tail is over here. And what we need to do, we need to remove the first element. So how can we remove that? You can just check out the functions over here, but to save the time, I'm just going to show you the function which is basically clear or arrays, right? So you will find this one. This is basically going to remove from the vector either a single element or a range of elements. So here we just need to remove a single element. The position is not an integer, it's a pointer. So here you can see it says the definitions iterator position and iterator first and iterator last. Well, you can go with any of this. The only difference is that it has a constraint, but you don't have to know at this stage, right? You can, well, you can just go and search what these two things are. Basically, they be the same thing. And how to use that? You can see an example over here. It says dot erase my vector dot begin plus 5. So plus 5 is basically going 5 steps away from the first element, which is basically the sixth element. And that's how you use this arrays function. He has also shown an example to delete a range. Well, we are not quite interested in erasing a range. We just want to erase a single element, which is going to be our first element because our first element is the tail. And what we can do, we can just say my vector dot begin plus 0, that is stay at the first element, or you can just omit the 0 and just say my vector dot begin. That is going to erase the first element. So let's implement that. What we're going to say, we're going to say body dot erase, and what we're going to erase, we're going to erase the first element, which we can get by body dot begin. This is the pointer for the first position, right? So this will basically erase the first element from our list. And well, before proceeding, let's first see whether this is working or not. Right? And we need to create another function. Well, let us keep this function for now and then create another function just in case something goes wrong. So vector, and it is going to be coordinate, right? We need a coordinate vector to be written. Well, basically we are going to return the snake's body. So snake, and then let's say get body, and inside this we can say return body. And in the snake.h, you can just create that function definition, which is basically vector chord. Sorry, what is that? Get body. Right. So now we have updated the snake's definition. Now we'll just update the board. And what we need, we first need a vector to capture the snake's body. So vector chord, let's say snake body equal to snake dot get body. And inside this, what we're going to do, well, just remove this else and we'll place this afterwards. What we're going to do is, inside the else, we are first going to loop through the snake's body and see whether any coordinate matches or not. So what we can do is, we can just say this body part, which will stay false in the beginning, right? We'll change that in the loop. Now what we can say is for int, well, I just used it, so k equal to 0, k is less than our body, which is snake body dot size, and k plus plus. What we're going to do here is inside this loop, we'll say if ith coordinate, which is basically going to control the y coordinate, is equal to the snake body of the kth index dot x, sorry, dot y, and j plus 1, well, remember that's the logic we were messing up, equal to snake body dot, sorry, snake body of that particular index dot x. If these things match up, then what we need to do, you need to display a body part. So let's just go with this small o for now. This is our body part. And if body part becomes true, equal to true. And what else? Well, we don't want to run this thing, right? Because at an instant, a particular body part can stay only at a particular location. So if that location is occupied, it is pretty obvious that any other body part won't occupy that location. So you can safely break out of this loop. You can end this loop. And in the end, what you can say is if it is not body part, if not body part, then obviously it is going to be just an empty space denoting the empty area, right? And here another thing is, here we are going to body dot size, but remember body includes the head, right? So what we can do is we can just say body dot size minus one, which will basically leave out the last element. And now this should work, and let's try to implement this. So F9, and here you can see that the snake has grown. So the other foot is over here. So well, I ate that, and the third foot is over here. Well, you can see that the snake is growing, right? So here you have four body parts of the snake, and now if I eat that, here now you have five, right? So now we have a working snake game, right? So now you have a working snake game, and this works pretty fine, right? So now the you can see that the animation also works pretty fine. The body parts seem to follow the head and so on, right? So this concludes our game. Well, I promise you that we'll be seeing how to create a teleportable wall. And before that, if you want to show a score, that is also pretty simple. What you do is you just say here int score. Well, just keep it global so that you can use it on the board function also. So here you can just say int score, which is going to be 0 in the beginning. And well, you can just set this to 0. In case you want to say play again, something like that, what you can do is instead of main, you can just say game, and this is going to be void game. Well, I'm not going to do that. You can do that, right? So if I want to play again, you can ask a question, do you want to play again or not, something like that. And if I press yes, then you can call this function again, and then you can set this thing as 0. So core equal to 0 before the beginning of the new game. And here what you can do is you can just say score plus plus, very simple. And if you want to give 10 points or something like that, you can just do that score equal to score plus 10, or any shorthands if you know score plus equal to 10 or something like that. You can do that over here. And here, before starting to print out the board, what we can do is we can just say see out our score. So score is our score, current score, and just add a couple of new lines so that it looks neat. And that should take care. Well, I have one returning function over here, that is this the snake pause, which is actually getting the position of the head, and we are also getting the position of the body, right? And we did not define the collision of the snake, right? So we'll do that, those things. First of all, let's just see whether this thing works or not. So now you have this particular snake, and I ate that, the score is 10. Now I ate that, score is 20. I hit that, score is 30, and so on. So it's working pretty fine, right? So you can close that. And to take care of the collision, well, you might have figured it out by now what we need to do. Well, what you need to do here is you need to say else, and you need to check whether it collided or not. How do you check that? Well, you don't need a else at all. You can directly check it inside a loop and then return it. So what you can do is for int I equal to 0, I is less than the body dot size. Well, it's inside the snake, so I don't have to call that. I can just say length minus one because I don't want the head, and it's going to be I plus plus. Right? And what we need to check, if our snake's head is basically pos, right? So if pos dot x is equal to any of the snake body, well, it is not snake body, it's just body of I dot x, and the y coordinate is also same. Pos dot y is equal to bodies I dot y. If these two things match up, just say return true. Yes, you collided. If these two things don't satisfy in the end, just say return false. So this should take care of the collision. So let's just try that out. So F9 to build and compile this, and here you have this snake and the foot. And let's first go for our first foot. We have grown, and the score is also increased. And the second foot, but it's going to take a while if I go like that. It's just going one body part at a time. But what I can do is I'll just right away collide. Well, how can I collide? Well, I'm moving left now, right? So if I just press right, I'm just going to collide with my neck. So basically, I collided, and now you can see that the process has stopped. Basically, our collision algorithm is working. So that basically ends this game. And if you want to make a teleportable wall, it's really simple. What you need to do is, I am sure many of you must have figured it out right now. Well, you just need to play with the coordinates. So here, if you see in the snake move snake, what you do is, if you want to change the location of the snake, you will just say here, if this particular thing, if position dot x is greater than the width minus 2, then what you do, you just say position dot x equal to 0. So simple. And again, what you do, if you say if position dot y, or sorry, position dot x is less than 1, then what you do, you just say position dot x equal to the width minus 3. Sorry about that. For random function, we need to use width minus 3, because for generating the random numbers in that range, so it's basically width minus 2. And this will make the side walls teleportable. So if you just save that, and now if you run this, you should be going through the side wall and coming from the other one. And now, if I go through my side wall, I should be appearing from the other wall. So you can see that it has been a kind of teleportation. Now, if I eat that, our tail will also follow our steps, right? So if you go from there, you appear from there, right? So it works both ways. Right? So that is how you make teleportable walls. And once you get to know about file handling, basically how to write files, what you can do is you can even have a high score option. So you can write down a particular high score on the file. So let's say I open this game right now, and I scored about 10 points and you scored about 1000 points. So that's pretty reasonable. I'm not a very good player, but yeah, so you score about 1000 points, and that is a high score, right? So here, if you run this program again, that high score gets lost. So instead of just writing it on the memory for that particular kind of run, what you can do is you can have a file where you can write down all your high scores, and then whenever you load this game, you load it along with the file. So inside that file, you have all the high score lists, and if you want, you can just have names also. So some games provide that, right? So you have the name and then the high score. Sometimes that you can design everything, and we'll come back to this while discussing files, right? So because traditionally what we do is we just write files about students and all this stuff. But we'll come back here and we'll try to work on this game more and try to create a file. And again, this is a totally working game. And if you want to implement this, and if you're comfortable with implementing this with this kind of a vector, well, I made some redundant functions. Like this is completely, sorry, this one is completely unnecessary because I'm getting the head along with the body. So you can take care of that. And again, I will advise you not to use a vector, use a list. And here, if you want to include another teleportable wall, which is at this one, you can do that again with a similar kind of logic for y-axis, right? So you make basically all four of the walls teleportable. So when I had actually implemented this game in Python, and if you use a graphics library, you will be getting results like that. So if we go to our Python one. So here I have my game. Well, it is basically written in two files. One has the classes and one has the script, and it has various images. So what I have is the snake in parts. So here you can see body horizontal, tail up, tail down. So whenever that snake is going in that particular direction, you show that image. And now, well, you can run this thing right over here. You can see this game, this is what you can make with a graphics library. Well, this is pretty fast, but this is what you can make with a graphics library, and you can see how smooth it is. And it doesn't have any kind of issues like moving down faster in the vertical direction, moving slower in the horizontal direction. It has kind of same speed because you can control it, right? You can basically control the number of pixels and all. And if you see, it is teleportable on both sides. If I go from the bottom, I end up from coming from the top, and if I go from the sides, I end up coming from there. So this is how you can implement your games, and this is basically the same logic which I've implemented, except that I have some additional functions handling the graphics of this game, right? Nothing more than that. It is basically the same exact logic which we have talked about in this console, but when you use a graphics library, you get results like that. So once you're comfortable with programming this
particular game on the console, I would advise you to look up some graphics library which is available in C++. There are many, so see what you're comfortable with and try to implement such games on graphics. Even the tic-tac-toe game can be implemented on the graphics library, and that really looks good instead of the console. Right? So, well, basically, what we are learning here is how to think, and console is the best way or the best platform to actually put down our ideas in a very fast way. Well, if I want to do the same thing in a graphics library, it will take a really long time. I need to initialize the graphics library. I need to do a lot of things before getting all these things, right? So if you're coming up with an idea, I would rather recommend you not to go to a graphics library, but first think and then put up a dirty kind of working prototype on your console, and then you can beautify it on the graphics library. So that's it for this particular video. Hope you enjoyed this, and I encourage you to build up your own game by changing the laws and then making it faster on the X and slower on the Y or something like that. I did not do that. I just went with a very simple approach, but I'm sure you can do that. And in the next video, we'll start with inheritance. Till then, happy coding.